All right, now this is the last example. We're still in quadratic, so we're still with the equations that are x squared. And so we're doing some word problems or application questions. And this is an open-topped box, and it's being made from a piece of cardboard. And it says the cardboard is 24. I'm going to make this one 24, and this is 16. So it tells us that this is the dimensions of the cardboard. And then it says if we cut this side out, so you can see that they've cut them out, and you fold this up, you fold these flaps all the way up, you would get a box. And it tells you that when you fold this up and fold this up and fold this up and fold this up, it tells you the area of this base. So the area of this base is 200, I think it said what, 250 centimeters squared. So that's the area of the base. And so what are we trying to do? It says, what is the side length of x of the square? So, because it said that these were all congruent, meaning they're all the same. So whatever size one box is, the other boxes are identical. And so you cut those out. So it wants to know what is the side length, x, of these squares. They're squares. So if you find out what this is, then you find out what that is. And that, because they're all the same. So we just need to find out what x is here, and it shows us that. And it wants to know what are the actual dimensions of the box. So I know the dimensions of the cardboard. The cardboard is 16 by 24. But when I fold this flap up and I fold this flap up, the box becomes a lot narrower. And same with this. If I fold that up and fold that up. So I have to fold this thing up. I'm going to get different dimensions of this box. All right. So one of the things that we can do is we can find out, we know that we're given the area. Maybe first I should mention, nowhere in here does it say that this is a maximum question. We are not finding a max or a min. So when this was titled Max and Min and Other Word Problems, this is the other. We already know the maximum area. We already know the area. The area is 250. So we're just trying to find out what it asks for. Nowhere in here does it say the word maximum or minimum or largest. So this is completely different. Now, what we need to do here is we need to find out what x is. And this is near impossible because we don't know what the area, actually we do know what the area of this entire thing is, but we know a little bit more. We know that the inside here is 250. But what we don't know is what is the side length of that? Because we know that this whole thing is 24, but what about this? And so that is actually pretty easy to do. It's 24 minus this distance. Well, what's that distance? Well, that's an x. And what's that distance? Well, that's an x. So it's 24, and you minus that x, and you minus that x, and you just get the inside. So if you have here, that distance is going to be, I don't know if I can zoom in here. Yeah. So this distance of this rectangle, which I'll do right here, this rectangle, is going to be 24 minus this x and this x, minus 2x. That's what this distance is. Now this distance, it says 16, that's this whole thing, but we're only looking for this part. So you can subtract an x, that's how big that distance is, and this is also an x. So this is going to be 16 minus 2x. So this distance is 16 minus x minus x. That would give you just the middle part, 16 minus 2x. All right, so I've got a rectangle that is 16 minus 2x is the length times the height, and we know that that would get you 250. So, A, we have length times the width. I'm going to write that without brackets. Length times width gets me 250, and one of them is 16 minus 2x's, and the other one is 24 minus 2x's, and that would get you 250. Now, we can multiply this through. 16 times 24 is going to be 384. And that is negative 32x. And that's going to be negative 48x. And that's going to be a positive 4x squared equals 250. So I'm going to rewrite this 4x squared out in front. And these two are alike. That gets me a negative 80. And there's a positive 380 equals 250. And I can subtract the 250 over here. Make it equal to 0. 4x squared minus 80x plus 134 equals 0. Now, this question is not, I do not need to find the vertex. The vertex is a maximum min. I'm not finding the maximum. I need to find x. So you could find x. You can try to do it by factoring. You could also do it by completing the square, but I'm actually just going to use the, whenever you're finding x, I like to try to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So you can write that down, positive, if you need to write down that formula. Now b, so it's a negative sign, and then b is negative 80, so again, negative 80, plus or minus negative 80 squared minus 4 times a, which is 4, times c, which is 134, all over 2 times a. A is going to be 4. So it looks like I've got 80 plus or minus the square root of something all over 8. So this right here, this inside negative 80 squared minus 4 times 134 ends up being 4,256. That would take a little bit longer to do without a calculator. I understand that. And even this, plus or minus 4, square root of 4256, that is a really gross question. It's not something that we can actually do. So what I'm going to do for this is I'm going to do 80 plus and then do 80 minus. So I'm going to do, there's two options. 80 plus square root of 4256 all over 8, and 80 minus the square root of 4256 all over 8. And we're going to do some approximations, and we're actually going to use a calculator for this one. I think there is one that can be done, I think, in the notes and maybe on our practice quiz that is done without a calculator. The numbers are small enough, but this one needs a calculator. So you can put this in your calculator. Make sure you put this in brackets and this in brackets, and you're going to get 18.15 and 1.84. I think we're dealing in centimeters here. So I'll let you write that down. Remember that this is our x. Our approximations, because they're not nice enough to be whole numbers. They're rounded. So that is our distance for x, 18 or 1 point something. So if this is 24, is it possible for this distance to be 18 and this distance to be 18? Obviously not. It's more likely that this would be, in fact, it's true that this would be 1.84 and 1.84. All right. So what we need to do, what are these? What are the dimensions of x? Well, they're 1.84 and 1.84. But what about the box? If you fold up the flaps, what is this box dimensions? Well, the cardboard is 24, and you minus a 1.84 and you minus a 1.84 from both sides as you bring it up. So you have 24 minus 1.84 minus 1.84, and you get your dimension. And you're also going to do it at the same time, 16 minus 1.84 minus 1.84 equals 12.32 centimeters. And again, that's just using my calculator. This 24 one was 20.32. So the dimensions of the box, So this, remember, was 24, but here it's only 20.32 because we took off the sides, and this was originally 16. Now this is 12.32. So that's the size of the box. I don't know how to draw a box. Something like that, where the flaps have now come up on either sides and up the top and the back and the front and all that. So that's the dimensions of this box that we've created. And if you multiply these, you'd get 12.32 times 20.32. You get 250.5456, which is a rounding, but that's really close. That's 250 centimeters. That would be the dimensions of my of the base. So that gets pretty close. So this question is completely different. Rewatch the video. This is probably the one that's most unlike everything else because we're not finding a max and min. So we started by saying, well, this cardboard was 16 by 24, but if we're just looking at the base, which is equals 250, this side is 24 minus 2 of the x's. This side is 16 minus 2 of the x's. And if I multiply those over here, I get 250. And I just did some algebra and used the quadratic formula and found my x to be two different numbers down here. One of them had to be rejected. And again, you can take a look at the notes online, and they're maybe written a little bit nicer.